All right, welcome everybody. Today we're going to talk about lesson number 32, and we're going to talk about finding equations of exponential functions. We're going to do this both with the graphing calculator, where it will say use the regression feature, and then also by hand, in which case it will say show all your work. Of course, make sure that you're not only answering the question, but that you're also explaining as we go through. So here in number 1, you are given the graph of an exponential function. Take a look at that equation. So A times b to the x plus 1 plus c. We're going to go ahead and answer the following questions. So what is the value of c in the equation, and also give a reason? So hopefully by now, that number by itself on the outside, we can pretty clearly say with confidence that that's the horizontal asymptote. So in this case, we could say that c is equal to -3 because y equals -3 is the horizontal asymptote. So then number 2, rewrite the equation using your value of c. Then we're going to go ahead and use the point -1, -2 to find the value of a. So we're going to go ahead and take our equation, which they gave us, f of x equals a times b to the x plus 1. And now we're going to go ahead and plug in our value of c. So then from here, we're going to go ahead now and solve for a. Notice that in order to do that, they're telling us to use the point -1, -2. Now, of course, if you were to look at this graph, there would be multiple points you could have chosen. So to be clear why you should start by choosing the point -1, -2 is because of the fact that up in the exponent was an x plus 1. Essentially, you should use the y-intercept whenever you're trying to find a, but because of the fact that that x plus 1 means that this exponential function went 1 to the left, that's how you know that you're going to use the point -1, -2. It does matter the order that you solve in, or else you're going to get different values. So now that I have my equation here, using the value of c, I'm going to go ahead now and plug in the point -1, -2. So if I do that, I am going to get that -2 is equal to a times b, and then -1 plus 1 minus 3. Again, the key step here is the fact that this -1 plus 1 is going to cancel out to be 0. When you get b to the 0, b will disappear, which is how you're allowed to solve for a. If you had chosen any other ordered pair to use in this first step, b would not disappear, in which case you wouldn't have enough information to solve. So in this next step here, I'm going to go ahead and add the -3 to the left-hand side. So that's going to give me a 1 is equal to a times b to the 0. Again, b to the 0, anything to the 0 is just 1. So I can safely conclude that a is equal to 1. The fact that it's a positive is good because this looks like growth and it's above the horizontal asymptote. So far, so good. Something that's not mentioned specifically, but I do want to go over, is a little bit of new vocabulary. So we have been talking about the end behavior, the right-handed behavior, and the left-handed behavior. So there is one slightly new word I want to use. Maybe you've heard it before. But let's say that I was talking about the right hand end behavior of this graph. What I could say is that as x goes to positive infinity, I could say that f of x increases without bound. So that expression there, without bound, again, maybe you've heard it before, maybe not. But what's happening on the right-hand side of the graph, you can see it's getting bigger and bigger and bigger, going up to infinity. If it keeps going up to infinity, there's no way for it to stop. So you can either say that that's without bound. You can say unboundedly. There's lots of ways to say it. That's just one example. Let's then also go ahead and talk about what's happening on the right hand. The left hand. So for the left hand, you would say as x goes to negative infinity, f of x decreases. And here you would say with bound. You can also say boundedly. The reason why it's with bound is because even though it's getting smaller and smaller and smaller, it is approaching the horizontal asymptote. So because of that fact, if there is a value that it's heading toward, we call that a bound. So again, important that you know the two different variations here. If it just keeps getting bigger and bigger and bigger, you would say without bound or unboundedly. If it's getting towards an actual value, you would say with bound or boundedly. So something you'll need for the homework tonight. Going back to the problem. So we have already concluded what C is based on the horizontal asymptote. We then solved for A. We now have to solve for B. In order to solve for B, we have to find some other additional point on the graph. Try to find an easy one if at all possible. So I'm going to go ahead and use the point 0, -1. So the point 0, -1. Oh, sorry, that's a little too skinny. So 0, -1. So if I choose the point 0, -1, I'm going to go ahead and say that -1 is equal to, we said that A was equal to 1, and then B raised to the 0 plus 1 minus 3, and that's of course a multiplication. I'm going to go ahead and add the 3 to the left-hand side. That's going to give me a 2 would equal B to the first, which means that I can safely conclude that B is equal to 2. So looking back at each of the previous steps, I was able to deduce C from the horizontal asymptote. I was able to solve for A. I was able to solve for B. So ultimately, if I put that all together, what is the equation? I can safely say that my final equation here would be f of x is equal to 1 times 2 to the x plus 1 minus 3. And of course, you could put that one or not put that one out front. It wouldn't matter. So that's the ultimate goal here. This is how you would find an exponential equation by hand. So not terribly difficult. I'll try to give you ones that work out relatively nicely, but important that you know the difference. So in number 4, you have yet another equation, and it's asking you to do a similar scenario here. So you are trying to find A, B, and C. Notice that when it comes to the exponent, there's just a single x there. There's no transformation left or right. So that will help us determine the order in which we should solve for things. So just like the previous problem, the first thing that we should deduce is the value of C. The value of C is the horizontal asymptote, which in this case would be 4. From that point, we could call it f of x or g of x, sorry, they call it g of x, would be equal to, so a times b to the x plus 4. And then again, how do I know what point to pick first? Because of the fact that there is no transformation, there's just an x, that's how I know that I want to choose whatever value would give me b to the 0. So that's how I know that I'm going to choose the y-intercept, 0, 2. So if I do that, I'm going to say that 2 equals a times b to the 0 plus 4. If I go ahead and subtract the 4, I'm going to get -2 equals b to the 0 will cancel. And now I know what a is. So I have a and I have c. If I go ahead and plug that in, g of x equals -2 times b to the x plus 4. I now need to find any other additional point on the graph. Again, try to keep it simple. So I'm going to look for an integer with looks like the point 1, 3. So 3 is equal to -2 times b to the first plus 4. Subtract the 4, which would give me -1. Divide by -2, and it looks like b is going to equal a half. If you then go ahead and plug that all together, you're going to get that the function is g of x equals -2 times 1/2 to the x, and then ultimately plus 4. So again, find the horizontal asymptote first, then use whatever value would give you b to the 0 to solve for a, and then use one additional point to go ahead and solve for b. It says, do the values of a and b that you found for g of x make sense in the terms of the graph being an exponential growth function? Explain your reasoning. So a couple different ways you could say this. So since a is less than 0, there was an x-axis reflection. but no y-axis, since the x is positive. So basically, since B is between 0, 1, 1 and 1 reflection, growth makes sense. And that's really not very eloquent at all. But again, if you take a look at your function, the fact that you got a 1/2 inside, the fact that the equation says decay, but your graph is growth, the reason why that happened is because of the reflection. So as long as you kind of hit all those notes, that's really what we're looking for here. So it looks like we have another example here. So find the equation of g of x equals a times b dx plus c if g to the 0 is equal to 2 and g to the negative 4 is equal to negative 2. Then they tell you that as x goes to infinity, g of x is equal to 3. So in that final step there, that's really just a fancy way of them telling you that that is where the horizontal asymptote is. So that, of course, is going to be your c value. So we can say that g of x would be equal to a times b to the x plus 3. Then which point do I pick next? I pick the one that gets b to the 0. So I'm going to go ahead and say that 2 equals a times b to the 0 plus 3. Subtract the 1. A is equal to negative 1. Then if I go ahead and use my additional point here, I can go ahead and say that negative 2 is equal to negative 1 for A, B to the negative 4 plus 3. I'm going to go ahead and subtract the 3. If I subtract the 3, that's going to give me a negative 5 equals negative 1, B to the negative 4th. If I go ahead and divide both sides by a negative, I'm going to get 5 equals b to the negative 4th. So b to the negative 4th, a couple different ways you could rewrite that. So I'm going to say that 5 is equal to 1 over b to the 4th. And then using just rules of algebra, if you have 5 over 1 is equal to 1 over b to the 4th, you can actually find the reciprocal of both sides. So you could say that b to the 4th is actually equal to 1/5. And then in order to solve for b, you would actually have to take the 4th root of both sides. So if you take the 4th root of both sides, b is equal to the 4th root of 1/5. You could leave it like that if you wanted to, or if you're going to put it in your calculator, you're always going to round to 3 decimal places, which would be 0.669. Which means that ultimately your final answer would be g of x equals negative 0.669 to the x plus 3. So notice that it is possible by hand to get a messy value, but not the end of the world. Notice also that that was a lot faster than the first two. So the more you do of them, the better that you get. And then finally, just make sure that if you are rounding anything, you are rounding to always 3 decimal places. That is the AP standard. So then what if you don't want to do it by hand? What if instead you actually want to use the graphing calculator? So let's go ahead and do one on the back like that. In order to use the graphing calculator, you would have to use the regression feature, and you would have to then get your answer in the form a times b to the x. So notice here that you have a pharmacologist testing a new antibiotic, very appropriate given our COVID situation. At the beginning of the first day, there are 2,500 bacteria. Notice that that does not appear anywhere in the table, so you actually should add it in. On day 0, when this experiment starts, there are 2,500 bacteria. Then they give you a couple of values based on each day. Then they first want you to just make a general equation or a general observation. Based on the data in the table, is this exponential growth or decay? And I think you could pretty clearly say that this is decay. Why? Because as the day number increases, the number of bacteria decreases. And again, you don't have to make your explanations long or lengthy. You just have to make sure that they get kind of right to the heart of the matter. So we're going to go ahead now and use the regression capabilities of the graphing calculator. And again, we're going to round to 3 decimal places. So it's been a minute since we've done regression. So I'm going to go ahead and pull up my graphing calculator. You might want to pull yours up as well. So here's my graphing calculator. And remember, if you're doing any of this statistic stuff, you're going to go ahead and start by pressing the second y equals. That's going to bring your stat plot up. And you want to make sure that number 1 is now on. So I already turned mine on, but you want to make sure that your plot 1 is now on. If you want to go ahead and enter the data, you're going to press the stat key. You're going to choose the edit. So choice number 1. And then you're going to go ahead and enter the day number into list 1 and then the bacteria into list 2. Notice again, I've already done that, but you can certainly follow along for yourself. Notice I also included the 0.02500. And remember, you don't have to put the data in order. So I put it at the end, which is perfectly acceptable. Once you have the data in, and preferably it's list 1 and list 2, if you have any data in there, get rid of it and make sure you're in L1 and L2. Then go back to the stat button. Remember, that's where all the good stuff happens. Stat, and then you're going to go to calc. So once you're over at calc, you're going to see all your different options here. You're going to make sure that you choose the exponential regression. List 1 and list 2 should appear. Hit enter a couple of times. That's ultimately going to bring up your equation. So notice you have your A and you have your B. We're now going to copy that into our notes, and we're going to, of course, make sure that we round it to exactly 3 decimal places. Sorry, don't mind me. I'm just detaching and attaching my tablet here. So if I go back to my notes, based on what I just found, I'm going to go ahead and say that this function, f of x, is going to be equal to 2629.226 times 0.838 to the x. So that is my equation using the exponential regression. How many bacteria will there be after 10 days? So after 10 days, that means you're finding f of 10. So that would be 2629.226 times 0.838, all raised to the 10th. If you go ahead and calculate that, and you're going to get 449.023. So that, of course, is the number of bacteria present at the end of 10 days. Then on what day of the experiment would you expect the number of bacteria to be below 100? Explain your reasoning. So a couple of different ways that you can do this. I think the easy of which is to go back to the graphing calculator. So if I go back to my graphing calculator here, I'm now going to go to the y equals, and I'm going to type in my equation, which again, if you take a look here, I've already done for you. So if I go to my y1, I'm going to get 2629.226 times 0.838 to the x. That is the equation that I found. Because the values in question I am talking about in comparison to 100 bacteria, that means that I am now going to go down to y2, and I'm going to type in 100. Then I'm going to graph. That is going to bring up not only my exponential function, but also my y equals. Of course, if you look here, you can see that I don't see it. That means there's a window issue. So in terms of the x's are the number of days. How long will this experiment go? Not sure, but let's say 20 days maximum. If you look at the number of bacteria, because the number of bacteria is decreasing, I don't have to choose a very large value. I know that I want 100 to be important, so I'm going to make it slightly larger, like 150. If I then go ahead and move to my equation, I can go ahead and see where the point of intersection is. And again, it's not actually the best picture, but you could go ahead and adjust the window as needed. The truth is, as long as I have that intersection point there, that's really all that I care about. So remember, to find that point of intersection, you're going to do second trace. Then you're going to choose the intersect option. You're, of course, going to find your blinking cursor. So curve 1, curve 2, guess if you're fancy. Otherwise, go ahead and find that intersection point. So 18.498. I'm going to go ahead and take that and write it here. So on what day of the experiment would they expect to have the number of bacteria to be below 100? Explain your reasoning. So let's say the number of bacteria equals 100 when X equals 18.498. So on day 19 or beyond, there will be fewer than 100. Okay, and finally, last but not least, will the bacteria ever be completely gone? Explain why or why not using your knowledge of graphs of exponential functions. So here's the thing. F of x has a horizontal asymptote at y equals 0. Remember, if you go back to your equation, because of the fact that there's nothing in back, no plus or minus, that's how I know that the horizontal asymptote is at 0. Oops. So f of x has a horizontal asymptote at y equals 0. So even though the bacteria continue to decrease, the total number can never be 0. That's the whole point of a horizontal asymptote. So even though there's eventually going to be a microscopic amount of bacteria, it technically is still going to be there, and that's because of the horizontal asymptote. So not really, I think, a difficult lesson, but an important one. So you're going to go ahead and try now the corresponding homework, number 32. There is also not only multiple choice questions, but some free response, open-ended. So please make sure that you are giving each of them the time they deserve. So thanks very much for tuning in, guys, and we will catch you next time.